Hello there, and welcome back to the next video. We are still in our chemistry chapter. We're getting closer to the end though with every video. I'm on page 36 of your student text. And please don't panic. We're going to talk about what all this means very slowly and walk through what is happening in this picture. I do want to remind you, in the last video, I asked you a question here on page 35. We had this equation. I asked you if that equation is balanced. So we are going to look at this and see what we can come up with. These two go together. So first, let's focus on what is happening in this illustration on page 36. I'm going to zoom just a little bit, or actually quite a lot. I want to focus in on this particular piece of this picture. So we are just looking at this particular piece. I want to explain to you how to read this. The picture is important. Let's take a look right here at, let me think about how best to do this. I think I'm going to highlight to start with. This C, which stands for carbon, goes with this C that is right there. So there is one carbon atom, and there are two oxygens. So there's two oxygens and one carbon. That is a molecule. Let me do it this way. This is one molecule of CO2. One carbon, two oxygens. And hopefully that will ring a bell. This is carbon dioxide. CO2 is carbon dioxide. So if we look back at this picture, you can see that I have drawn 6 of these. There's 1, 2, 3, 4, 5, 6 molecules of carbon dioxide. And that's exactly what this formula is saying to me right here. Let's go ahead and write what that says. 6 molecules of carbon dioxide. Di, D-I, means 2. And I apologize if I'm a little bit out of breath today. I'm having some issues with my asthma. So if I sound a little funny and like I'm out of air, it's because I am. So I apologize, but I know that some of you are waiting on me to get this finished. So I'm trying hard to get it done. Okay, this one, we have, here's a hydrogen, and we have 2 of those. Whoops, I did it in the wrong color. Trying to keep my color code. That would be blue for hydrogen. We have 2 of those, here and here. And then we have an oxygen. And remember, if we don't have a subscript right there, that just means 1. So there's 1 atom of oxygen. And you know, hopefully, what H2O means. H2O is water. So this is 1 molecule of water right there. And we have how many? 6 of them. So let's look at this picture. Whoops. And make sure there's 1, 2, 3, 4, 5, 6 molecules of water. So I am mixing carbon dioxide and water in equal amounts. So 6 molecules of water plus 6 molecules of carbon dioxide. Both of these are in the left side of the equation, and this is called the reactants side. This is one of your definitions. So these are the reactants, and that should not be capitalized. I don't know why I did. If you did, it's okay. It's not a terribly important deal, but I try to model good grammar as best I can. Okay, so we mix carbon dioxide and water, and then here's what we come up with. This very long molecule, C6H12O6, is one molecule of glucose. And I'm just going to call it sugar because I want you to think of it in as practical terms as you can. So this is one molecule of sugar. Technically, these need to be combined for it to be a molecule. I just didn't do that for the sake of confusion. And again, I'm going to show you something here in just a second where I need them to be in a line. So, one molecule of sugar. And over here, tell you what, let me move this up just a hair, because I want you to be sure that you know that all of this is one molecule of sugar. So to make sugar, you need carbon, hydrogen, and oxygen. And then this, do you remember what O2 is? It's oxygen 2. That is breathable oxygen. So this is 6 molecules of breathable oxygen. Not ozone or O1. This is 6 molecules of oxygen that you and I can breathe. And this side of the equation is called the product side. So if they give me this very complicated formula on the test and they say, what are the reactants? I would say carbon dioxide and water. If they say, what are the products? I would say sugar and oxygen. And if they were to ask you about the catalyst for this reaction, that's going to have to, you have to have sunlight for this to occur. So you might be thinking, what in the world is all of that? What does all of that mean? This is the formula for photosynthesis. And let me break that word down for you too. The formula for photosynthesis. 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 And here's a morpheme. Photo means light, and synth is to create. So let's go to our morphemes page and see if we already have these. And we may, because we're moving right on through this stuff. I don't believe I do have either one of those, so let's add them. 2 morphemes in this word. Photo is light, and synth is create or make. I'm going to use make because that's easier to spell. So the morpheme is photo and synth. So this is what is happening in this formula is the photosynthesis reaction. And this is how plants make food. So let me go back here and show you. Plants use carbon dioxide and water in the presence of sunlight to make sugar, and they also release oxygen that we need to survive. If you think back to the carbon cycle, when we breathe out, we're releasing this carbon dioxide right there. When plants produce sugar, they release oxygen as a byproduct. They don't need it, so they put it out into the atmosphere. That's why we need plants, because they help to produce the oxygen that we need to breathe. So this byproduct, even though the plants don't need it, we do. So they're putting that back out there for us to breathe. We rely heavily on plants. Okay, so photosynthesis is the process that plants use to make food. Plants can't get up and move around, so they have to make their own food. And when we get into the life science, we'll know more about that. But for now, this is the chemical equation for the process of photosynthesis. Photosynthesis is one word. It kind of looks like two words there, but it is one word. Okay, there's one other thing that I want to remind you of. Remember, with the law of conservation, we said that matter is neither created or destroyed. That was one of your terms. So the atoms in the reactants must equal, if the equation is balanced, it must equal the atoms. I'm having an awful time today. The atoms in the product. Okay, so let's see if that holds true here. If you need to pause the video to write this down, that is fine. Okay, so let's look back at our reactant side. And I literally am just going to count the number of oxygens. So I'm on the reactant side, and here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 oxygens. And I won't do this the next time now that you get the idea. So in our reactants, we have 18 oxygen atoms. Okay, let's count the C's in the reactants. Those are the yellow ones. 1, 2, 3, 4, 5, 6 carbon. And I'm not saying C6 because they're not connected. I'm just counting them. In hydrogens, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those H's. Now let's do the same thing for the product side, which is the end result of this equation. So let's count the O's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 oxygens. That's looking awfully good because they need to match. How many carbons? Well, we have 6 of those. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at that. Even though there has been a reaction, and we have a completely new substance at the end, the atoms do not change. There are 18 oxygens, 6 carbons, and 12 hydrogens in both sides of the equation. This is a very good thing. That is the law of conservation. And we say that this is balanced because all of those check out. They match up. So this equation is balanced. So let's drop back one page and look at this one. Now, what if you get this on a test and they ask you the question, is the equation balanced? I don't want you to have to draw all of those circles and write all that stuff. You don't have time to do that. So we're going to use some mathematics to see if this equation is balanced. And I'm going to zoom in, so if this makes you motion sick, just close your eyes for a second. I'm going to zoom way in here so that all I'm looking at is this. Okay? All right. So what this is saying to me, we know that this says 6 carbon dioxide molecules. Okay, let's go ahead and put the ghost 1 in here because you won't see it, but you need to know that it's a 1. And then we're going to use some multiplying to get this without drawing it. So to find the carbons, I'm going to say 6 times 1. 6 times 1 is 6. So 6 carbon. Now to get the oxygens, I'm going to say 6 times 2. 6 times 2 is 12. Use your fingers if you need to count those up. So 12 oxygen. These are atoms that we're talking about here. Just like on that other page I drew the little circles, this is going to save you from having to draw them. Okay, so let's slide on over here and let's check this one out. Remember, you can put your ghost in there. So here is 6 times 2, that's 12 hydrogens. And then 6 times 1 is 6 oxygen. Okay, I'm going to zoom out. So here I have 12 oxygen and 6 oxygen. That's a total of how many? Whoa, that didn't work out. Let's try that again. Okay, sure it's going to work. Let's try there we go. 12 and 6 make a total of 18 oxygen. So let's simplify that. And this is our reactant side. Okay, so let's try the product side. We need to do the same kind of math. Here's the catalyst, that light energy, but here's what we need to check on this side. Now this one doesn't have a big number out front. It's just plain old, we just read it. So we have 2 carbon atoms. We have 12 hydrogen atoms. And we have 6 oxygen atoms. And then to get this one, we do have to multiply because we have a big number that's called a coefficient, and we have a subscript. So we have to multiply those two together. 6 times 2 is 12 oxygens in this part. So again, I need to add, if you have more than one, these are both oxygen. And guys, I am so sorry. I'm having awful time with my iPad today. It just doesn't want to cooperate with me. It's a Monday. So we have a total of 18 oxygen. So let's see if our equation is balanced, because remember that was the question we needed to answer. So let me zoom a little bit and let's see. Here's the the dividing line of the equation. So let's see if it balances. Oxygen and oxygen, those match. So far, so good. Hydrogen, 12. Hydrogen, 12. So far, so good. 6 carbon. Whoa. 2 carbon. Do you see the problem? This is not a balanced equation because the carbons don't match. The reactants have 6 carbon, the product has 2, and the law of conservation says that matter cannot be created or destroyed. So it is not balanced, it violates the law of conservation. This side, the product side, is 4 carbon short, or let's say is short 4 carbon atoms. So that cannot happen. The law of conservation tells us that we need a balanced product for our reactants. If you decide to go on to school, you're probably going to encounter something like this again, depending on what you choose to study. If you want to study cosmetology, you're probably going to see quite a bit of this. Not this particular formula unless you're dealing with plants, but mixing chemicals to put on people's hair for dyeing their hair, coloring their hair, is very much dependent on chemistry. So don't think that you will only see this if you're going to be a doctor, because you may see this in any field, because chemistry is important to everything we do. We will see this formula again a little bit later in the very last module, which is about life science. Here it is. It's in the photosynthesis terms. So this will come back a little bit down the road. This gives you a view of where we are. We are currently right here. So we've got a ways to go, but it will be coming back. Okay, I hope you've enjoyed this video. I know it's very difficult to understand. Just do the best you can and don't fret about it. It's okay. If you don't understand this one, focus on others and you'll still be just fine. If you have questions, please contact me. I will be happy to help you. Have a great day.